In this lesson, we're going to learn how to perform polynomial long division, which is very closely related to the long division you've done with numbers back in elementary school. What I'm going to do then to introduce you to polynomial long division is give you a problem that involves just numbers so that you have something to kind of relate it to when you're doing the polynomial long division that's new to you in this section. What I want you to do is fill in the blanks to complete the numerical division problem below. I'll do you the first step, and then I'd like to see if you can fill in the rest on your own. Now, the number I'm dividing into is 3,105, and it's already got a 2 here and a 24 here, which tells me that 2 times whatever is my divisor, what I'm dividing by, is 24. That means this must be a 12, because 2 times 12 will give me that 24. If you remember, then what you're supposed to do is subtract that from 31, and that would give you 7. Now 12 doesn't go into 7, so you need to bring down the next digit of a 0. Now 12 does go into 70, and the number of full times 12 goes into 70, I believe, is 5. 12 times 5 is 60. If we did 6 times 12, that would give us 72, and that would be too much. So if we subtract those off, we'd get 10. 12 doesn't go into 10, so we need to bring down the 5. Now 12 does go into 105, and I think the most we can bring 12 into 105 is 8 times, because 12 times 8 is 96, and if you subtract that, you're going to get 9. Now 12 doesn't go into 9, so that is our remainder. Now let's refer to those as we fill in some of the vocabulary that's on the next page. In this division problem, the dividend is the number you're dividing. That's 3,105. The divisor is just what you're dividing by. It was 12 in this problem. The quotient is your answer, 258, and the remainder was 9. How could you use multiplication to check the result of this division problem? Well, you might recall, I think all you have to do is multiply your divisor by your remainder, 258, and if you did that, I think you'd be 9 units short of your dividend, so you'd have to add on the remainder. So I believe if you did that, you're going to get the 3,105. For number 4, it says, how did you decide what number should be subtracted at each step? Well, basically, I think what you had to do is see how many times your divisor went into whatever digits of the dividend you happen to be looking at. So I'm not going to bother writing that down for time's sake, but kind of what is important is maybe number 5 is, would the results be different if you changed the 3,105 to 315? Explain the importance of using 0 as a placeholder. Well, I think you might be thinking, of course, if you divide these are going to be very different solutions. That 0 makes a big difference. 12 goes into 3,105, 258 times with a remainder of 9, and only 315 would be a lot less. So you have to have 0 as a placeholder, and that's going to come into effect when we talk about polynomial division very, very shortly here. Now, from that warm-up, we saw that 3,105 divided by 12 is the same as 258 with a remainder of 9. This is the same thing as 3,105 divided by 12 is 258 plus 9 over 12. That number is 258.75. 9/12 being that 0.75, right? It's 3/4. Now you might be thinking, like, where did that come from? What is that remainder 9? Do you remember that last step when we had that little 9 at the end of the road there? What we would really try to do is we still needed to divide whatever that is by 12. We just stopped because we couldn't do it. Well, that's at least what you did when you're in elementary school, and it wasn't nice. You'd get a decimal. Well, that decimal is 9 over 12, and that's 3/4 or 0.75. In general, when you're ever talking about dividing polynomials, it's the following. You're going to have your dividend over your divisor equals the quotient plus the remainder over your divisor. That's just general division right there. Now, let's go ahead and apply that to some polynomial long division. I'm going to do one example for you. We have 2x to the fourth plus 3x cubed plus 5x minus 1, and we're dividing it by the polynomial x squared minus 2x plus 2. What you're dividing is your dividend, and what you're dividing it by is your divisor. Okay, so what we're going to try to do here is long division. We're going to put, actually, let me maybe set that over here so we don't run out of room. We're going to put the divisor inside that little division bar. It's 2x to the fourth plus 3x cubed. Now notice something here. There is 0 x squareds, right? There's that 0 x squared term that's not there. That's our placeholder we need to make sure we include. If we forgot a 0 x squared, that would be very similar to making the mistake of dividing 3,105 and instead doing 315 and forgetting the 0. It's very important you have that 0x squared as a placeholder. And then I'm going to do plus 5x minus 1. Now I have all of the terms of that polynomial in standard form, even the missing terms. For the divisor, I would do the same thing. Put in all terms, even any missing terms, and in this case, it's a quadratic, and I don't have any missing terms. I have my x squared term, my x term, and my constant. Now, guys, to start this off, look at only your first term of the dividend and the first term of your divisor and divide those. Don't look at the rest of it. So don't look at that and don't look at that. Those are inconsequential. You don't need to look at those yet. So if you divide 2x to the fourth by x squared, you would subtract the exponents and you get 2x squared. So the first term of my quotient is 2x squared. Now you remember, when you did this with numbers, you multiply the first term of your quotient to your divisor and you write the result underneath. So I'm going to do the same exact thing. If you multiply 2x squared times x squared, you get 2x to the fourth. And by the way, if you did it right, those terms better match up. Exactly. 2x squared times negative 2x is negative 4x cubed. And then I also have to multiply 2x squared to 2. That would be positive 4x squared. Notice how I lined up all the like terms underneath one another. I have the x to the fourths lined up one above the other, the x cubes, and the x squareds. Now, this is where it gets a little tricky. You may recall that what you need to do at this stage is subtract this entire number or polynomial from the dividend. That's what we did before when we did the long division. So if I subtract that, would you agree that I would need to distribute that minus sign and then I can just add them down? So that's what I'm going to do. If I distribute the negative, I don't want to do that. Let me distribute the negative. So this becomes negative. If I do minus negative 4x squared, that becomes positive. And then instead of a positive there, this would become negative. So change your signs, because remember, we're subtracting off. If we do, these cancel. 3x squared plus 4x squared becomes 7x, those x cubes rather. 0x squared minus 4x squared is minus 4x squared. Now what I'm going to do is, I'm going to drop down the next term only, the positive 5x, and you're going to see exactly why in a second. Now guys, we're at the stage where we need to now find the next term of the quotient by looking at the first term of this new dividend. I don't care really about these guys anymore up there. I'm going to look at the 7x cubed and the first term over here of my divisor, x squared, and I'm going to divide those. 7x cubed by x squared will be 7x. That's my next term. It's a positive 7x. If I multiply 7x let me erase some of the steps from the other part so it's not so crazy looking. Oops. That was an inopportune timing of a phone call there. If I do 7x times x squared, I would get 7x cubed. We're going to write that underneath that next term. Remember, we're going to end up subtracting this off. If I do 7x times negative 2x, that's going to be minus 14x squareds. And if I do 7x times 2, that's going to be positive 14x. Now, if you recall, what I have to do is subtract this off of that polynomial. So I'm going to change the signs from a positive to a negative there. This is negative, it's going to be positive. And this was positive, I'm going to change it to negative. And I'm going to add them up. So 7x cubed minus 7x cubed cancel. They should, if you did this right. Negative 4x squared plus 14x squared will be positive 10x squareds. And then 5x minus 14x is minus 9x. I'm going to drop down now the minus 1. Now what I need to do is see how many times I can divide 10x squared by x squared. So the next term of the quotient can be found if I divide 10x squared by x squared. And that is just 10. So I'm going to have a positive 10 here. Let me erase the work from the previous step. Now what I have to do is multiply 10 to the 2x, or to the just x squared. That'll be 10x squared. Notice how those match, and they should. 10 times negative 2x is negative 20x. And then 10 times 2 is positive 20. Now we have to subtract that off. That'll become a minus. This turns into a plus. And the positive 20 turns into a minus. If you subtract, these cancel as they should. Negative 9x plus 20x is 11x. Negative 1 minus 20 is minus 21. Now check this out. Negative 11x is not divisible, or that 11x is not divisible by x squared, right? I would end up with 11 over x. It just doesn't fit in a full number of times. Guess what this is? That is your remainder. You can't divide anymore. So to finish off the problem, guys, I'm going to go back to here. When you divide, you get a quotient plus remainder over divisor. Our quotient is right here. Right? It was a 2x squared. I think that little negative in front was really just a line from a step. It was just a positive 2x squared plus 7x plus 10. That's our quotient. Plus, we got to do the remainder, which was 11x minus 21. 11x minus 21 over the divisor, x squared minus 2x plus 2. So the result of this division problem is that crazy looking expression. We're going to have you guys try to do the following slide. Oops. What I'd like you to do now is try this self-quiz, these two problems, these two division problems on your own. And actually, I'm going to do you a little bit of a favor, because I know that it is tricky to start these up on your own for the first time. And I'll just set up at least number 1 for you, so you can hopefully get the rest going on your own. Your first thing should be to write the, let's see if I can fit it in here, the y squared minus y plus 1, that's your divisor. And inside the division bar goes the y to the 4th plus, now there's no y cubed, is there? So I got to do plus 0 y cubes, that's important. Then I got to do plus 2y squared, and then minus y plus 5. So minus y plus 5. Do I have all the terms there? Here's my y to the 4th, y cubed, y squared, y constant. I'm good. To get it started, divide y to the 4th by y squared. It's going to be a y squared first term. Now multiply y squared to your divisor, giving you y to the fourth. Y squared times negative y is negative y cubed. Y squared times 1 is positive y squared. Now remember, when you subtract this off, you have to change the signs of each of the terms here. So I'm going to change that to a negative, this into a positive, and I'm going to scratch that out and make it a negative. Then add up carefully. If you do this right, these first guys should always cancel. Then the next one's y cubed, or 0y cubed plus 1y cubed makes 1y cubed. 2y squared minus 1y squared is positive 1y squared, or just plus y squared. And I copy down minus y. Now I have to divide y cubed by y squared, giving me a plus y. Then I do the same thing. Y times y squared is y cubed. Y times negative y is minus y squared. And y times 1 is just plus y. Then you got to subtract it off. Minus, this turns to plus, then this takes to minus. Add them down. I'm going to stop there and let you try to continue with the process and get the answer on your own. For number 2, I would also like you to divide using long division. And we'll talk about it tomorrow in class. Thanks for watching.